Hi. This is the third session of our series on GIS tutorials. Last time, we have learned how to deal with the feature, or vector data using QGIS. Today, our main scope is to georeference the raster data to real Earth coordinate locations, and digitize some of the distinct man-made and other features from it. For this purpose, we will use a non-spatial raster data with distinct ground control points. Each ground control points have real Earth-bound coordinates. Using these given values, we are going to match the pixel coordinates of the image with the real locations on the Earth. Like the previous sessions, you can follow me from the handout as well. Download the raster data and extract it to an appropriate location. You will find a JPEG file, which is a non-spatial data. In order to georeference any raster using QGIS, a special plugin, called GeoReferencer must be enabled or installed. From Plugin menu, select the Manage and Install Plugin option. This will give us the list of plugin options. From this list, select the most appropriate option that suits your version of QGIS. Since some of the older versions differ drastically from the newer versions, the plugin that we are looking for might be already installed or activated. After the installation, it will bring a new option under the raster menu, which is GeoReferencer. We will use this menu, therefore select it. This will open up a new window. From the main menu bar of this window, select and add new raster using Open Raster option. Most important thing to do, at this stage of georeferencing is, to define and update, transformation settings. Please do not forget to update, coordinate reference frame. In our case, since all the ground control points are given in European datum 1950, UTM zone 36 north, please select this coordinate reference frame from the menu. By the way, do not forget to check the box for the load the results to QGIS when the process has been finished. Now we can add all the ground control points one by one. While doing this stage, in order to increase the accuracy of the georeferencing operation, I highly suggest you zoom in on the intersections as much as possible. After adding each ground control points, the table below the image is going to be populated as well, showing the stages and accuracy of each points. For example, it displays image coordinates with the relevant real Earth locations. After entering all the ground control points, we will examine the root mean square error of the process, whether it is within the range of the acceptable threshold values. For this one, it is quite remarkable, and we will continue to our process by selecting the Start Georeferencing option from the main menu. This will finalize the procedure and add the final georeferenced spatial data to the layers of QGIS environment. At this stage, we can check the resulting raster whether it is on the correct spot or not, by adding an underlying base map to the mapping environment. For this purpose, you can install Quick Map Services plugin. Add a new base map using Web, Quick Map Services, OpenStreetMap OSM, and Select OSM Standard. As you can see, almost all of the patterns of the image fit with the underlying base map. Now we can digitize features from this raster into a shapefile or to a feature layer. Like the last session, create a new shapefile, for example transportation, add attributes, ID, type, and length accordingly. Instead of freely creating features, we are going to digitize features using raster as a reference. Add all the features and some extra layers. This sums up our session. Today, we have learned how to georeference non-spatial raster data and digitize features. See you next time. Have a nice day.